We're now going to take a look at the antiderivatives for all the trigonometric functions. You see, so far we know what the antiderivative for the sine and cosine functions are. We also know what the antiderivative for the tangent function is. That was in a previous video. Recall that the antiderivative for tangent is negative the natural log of the absolute value of the cosine of x. And just quickly remember, the way we evaluated that was by writing the tangent function as sine over cosine. And then we let u equal the cosine of x, and we were able to find the antiderivative for the tangent function, and it's this. In a similar manner, we could find the antiderivative for cotangent, and it turns out to be negative the absolute value of the sine of x. We would do it in the same way. We would just write cotangent as cosine over sine and let u equal the sine of x. And we would get a result like this for our antiderivative. Now we want to find out the antiderivatives for secant and cosecant. And then we will know the antiderivatives for all the basic trig functions. Now to evaluate the antiderivative for secant, we're going to do a little math trick. Remember, there are two very common math tricks that we use. We add something in and subtract it back out. That's one of the tricks we use to complete the square or to prove the quadratic formula. And the other trick is to multiply something in and divide back out by the same thing. That's the trick that we're going to use here to evaluate this. So what we're going to do here is we're going to evaluate this by multiplying the secant of x by the following term. So we multiplied by secant x plus tangent x divided by secant x plus tangent x. So you see this quantity right here is just 1, so we haven't changed anything. Now what we're going to do is we're going to multiply the secant x into the numerator, and we're going to let u be the denominator, and then everything will work out nicely. So we'll write this then as So see, we just multiplied the secant into the numerator, and we get secant squared plus secant x times tangent x. Now what we're going to do is we're going to let u equal the denominator down here. So this is going to be our u. So if we let u equal notice that we then get that du. Okay, derivative of secant is secant tangent. And derivative of tangent is secant squared x. And then we have a dx. So this is what we get for du. Now you see, this is a very easy substitution. So the denominator becomes u, and everything in the numerator, along with the dx part right here, that just becomes du. And so this integral here then becomes the following. So we then get the integral of du over u. So this is equal to this down here, and that of course is a very simple logarithm. And substituting in what u is, we get our answer. And there you go. We have the antiderivative of secant x is equal to the natural log of the absolute value of secant x plus tangent x plus our arbitrary constant. So here is the antiderivative for the secant function. Now similarly, the antiderivative for the cosecant is this. So the antiderivative for cosecant is negative the natural log absolute value cosecant x plus cotangent x. Notice how the secant got replaced with cosecant, and the tangent got replaced by cotangent, and we did have to introduce a negative out in front. So now we have completed our antiderivative table for all of the basic trig functions, and they're as follows. So we have here antiderivative of sine is negative cosine. Antiderivative of cosine is positive sine. Antiderivative for tangent, as we saw, is negative ln absolute value cosine x. Antiderivative for cotangent is ln absolute value sine x. Here's the one we just did. Antiderivative for secant is natural log absolute value secant plus tangent. And the antiderivative for cosecant, we didn't do that one, but it's very similar to the secant. It is negative ln absolute value cosecant plus cotangent. And you notice there's a pattern here. You really only have to remember 3 of these and you can recover the other ones. If you think of partner functions, like think of sine going with the cosine, cosecant partnering with the secant function, and cotangent partnering with the tangent function, you really only need to remember these 3 right here. So you see, if you remember the integral of sine is negative cosine, the partner of cosine is sine, and you get rid of that negative. If you remember the antiderivative for tangent is negative ln cosine, you change the cosine to a sine, and you get rid of the negative here, and you get your antiderivative for cotangent. If you remember the antiderivative for secant is ln secant plus tangent, you replace the secant with the cosecant, the tangent with its partner, cotangent, and you put a negative in. We didn't have a negative here, so you make it negative, and you get your antiderivative for cosecant. So you see, you only really have to remember 3 of these, and think of the replacing terms with their partners, and then flipping the sign. And that completes our discussion about the antiderivatives of the basic trigonometric functions.